All right, let's get started. Let's do this. So last time we talked about Docker. We're going to extend that to Docker Compose now. And it's going to be even cooler than Docker. So our goal with Docker Compose, well, I'll back up a second. Let's review last time. Our goal with Docker was to automate the creation of Docker images, and then we used the Docker images to create Docker containers. So it was like a script that built our containers, our images and containers, and then we had some command line parameters that we had to give it when we actually created those things. We had to give it an image name. We had to specify which local port we're going to map to the container, and something else. Oh, something that we're not going to do yet today, that we'll do in homework too. But we had to specify some things. With Docker Compose, we're going to automate this even further so we can use one command and have all of our setup, all of our configuration, all already set in our files. We're going to add a docker compose.yml.yaml file, and that's going to have the rest of our configuration. So we can do one thing, docker compose up --build --force recreate. Command you'll probably run at least 100 times this semester. So get used to that one. It's a very powerful command. It's really docker compose up is going to say build my stuff, like do all the stuff. And then --build --force recreate is going to make sure that it's using your latest code. And I'll talk about that, and actually not much more depth than that in the later slides. So Docker Compose is going to automate building our images and running our containers in one command. That's what we want. Full automation. So when you build your app, you go to deploy, you go to your deployment server, you install Docker, you clone your repo, Docker Compose up. Done. Deployed. That's how simple we want things to be these days. And Docker really has taken over the industry. It's everywhere. At the very least, containerization. Some shops aren't using Docker specifically, but they're using some form of containerization, and most of them are using Docker. Not all of them are using Docker Compose, but they're all using Docker mostly. I don't know. I'm going on a tangent here. Anyway, this is stuff you're going to see when you graduate. Minor question, what does YAML file extension stand for? YAML. I answered it when I read the question. The .yml is YAML. We're going to see our Docker Compose file, so you'll see the format. There was a lot of competition for file formats for textual information. And for the internet, for the most part, JSON won that battle. So when we're transferring information across the internet, we usually use JSON. YAML is another format that represents the same types of information, lists and key value pairs, and data structures can be nested as much as you want. It's the same solution to the same problem, but YAML kind of won the configuration battle. If you have a configuration file for your project, usually YAML. I speculate, and what I agree with is YAML is more human readable. So it's a nicer format for files that are going to be read and written by humans. We like to use YAML, and it kind of won that battle. When we're transmitting information over the internet, that's usually generated by code and read by code. JSON's the winner of that battle. So it's another format that competed with JSON and found a home in configuration files. And the big reason to use Docker Compose, yes, we get rid of the -p and mapping the ports. We put that in an actual configuration file. But the big reason is that Docker Compose can manage multiple containers. So we will have multi-container apps. By the end of the semester, your app is going to be ran across 3 separate containers. It's going to be your app container, which we'll see today. We'll build that with Docker Compose. Then your database will be in a separate container. And finally, we're going to run Nginx also in a container. And we're going to run all 3 of those pieces of software with one command, Docker Compose up. It's going to build all 3 images, run all 3 containers, and have them interact with each other to form one single app. So that's what we're going to do by the end of the semester. Right now, we're just going to build one thing. Next week, we're going to add a database to that Docker Compose and have your app communicate with your database across containers. So that's the big reason why we want to go to Docker Compose. Since I kind of mentioned it, a lot of shops will use Kubernetes instead of Docker Compose to manage their containerization. Kubernetes is way more powerful once you get to really complex configurations. Kubernetes is, I already said it, but very powerful, very complex. But Kubernetes makes it harder to build simple apps. If you don't need the power of Kubernetes, you usually don't. But when you hear that, think Docker Compose, same problem, different solutions. Kubernetes is just absolutely bonkers, though. It can scale. Like if you have a complete server room filled with servers, a Kubernetes deployment will elastically scale up your app based on usage and use more machines and create containers on the fly. It's really, really cool stuff. Not needed unless you're like Google, but it's really cool. All right, so here's our Docker Compose file. I got this down as simple as I can. I used to introduce Docker Compose with 2 containers, with a database and everything. I got it down pretty simple so we can really understand this. Pretty straightforward this time. And just like the Docker file, this is mostly exactly what you'll need for your homework. You can use this as a template, as a starting point. There's not even much going on here, but what is going on, I made sure to add one thing that you do actually have to pay attention to what's going on here and change one value in this thing. Please don't come to office hours with this exact code and say, why doesn't it work? Please think about what you're doing. Don't just copy things from lecture. I know everyone does. That's why I add these things. That's why I don't have it exactly compatible with your homework handout, exactly out the gate. You got to think about this a little bit. And that's good because I'm going to talk about it for a little bit. Probably half a lecture, and then the second half of the lecture will be demos. I'll spin up some containers. And then Friday will be nothing but demos, by the way, just to give you a quick roadmap. Friday's going to be, I'm going to it will successfully be mostly homework hints, the common issues that you run into on the homework, showing what can go wrong, what, just live demos, a bunch of live demos that are common mistakes on the homework. All right, so Docker Compose file. First line is going to be the version of Compose that you're using, or not the version of Compose that you're using, the file format version of the Docker Compose file that you're using. So the first thing Docker Compose needs, it's going to go in and read this file. It needs to know what version you're using because there have been multiple iterations of this. The latest one is 3, and there is a subversion too. So 3 will take the latest subversion. And expect the format of the file to be following the format of that version, for what it's worth. So if you have the wrong version or this line's missing, Docker Compose isn't going to know how to parse your settings file. So 3 is the latest one. Use version 3. Don't have to worry about it. I've never thought about this aside from talking about it in slides. I just put version 3 at the top of my files. Okay, the rest of it we do got to think about. Services, this is going to be a list of services, and we can start seeing the YAML format here. This is going to start a list or any sequential data structure, whatever you want to call it. I think it's called list in YAML. And we're going to indent to indicate that we're in that list. So this is starting a list named services, and this list has one element named app. And then at app, we're indented, so app defines a list with 2 elements, build and ports. And ports is a key value store with one, that's not a key value store. It's another list, right? With one value that is a string. So services, we will eventually have multiple services, as I mentioned. We'll have 3 by the end of the semester. For now, we're just going to have one service, and I'm naming it app, because it's my app. So app, of course, short for application. But app, this is the name of the service. You can choose whatever you want for this name. Whatever you want to name your service. I mean, app is pretty standard. If it's what your app is, we'll have app and DB or Mongo and Nginx. Usually you name these meaningful things. But this is a name that you choose. There's nothing inherently special about this name. You can choose whatever you want for it. So we will see multiple containers eventually. That's where this name will be very important. You can still choose whatever you want for it, but you do have to be consistent. So when we do eventually have 2 containers, or even 3, when we have 3 containers that need to communicate to each other, to communicate, Docker will set up a network where the host name of each container is the service name of that service. So if I wanted to connect to this app from another container, I wouldn't say localhost 8080 or localhost 8000. I would say app 8080 or app 8000. Well, for this example, it would be app 8000. App:8000 would be the host and port if I want to connect to this app from another container in that network. So that we'll talk about a lot. Man, it is next week, isn't it? That seems so soon. Maybe it's in 2 weeks when we're going to add databases to this. I think it's in 2 weeks because next week's a lot of front end stuff. But this will be important when we get to that because that will become the host name of our containers. So something to keep in mind for now, name it whatever you want to name it because we don't have multiple containers that need to talk to each other. So we don't have to care that that's the host name yet. But keep that in mind. It will come back big later on. And then build, this is the other one I was trying to think of. Build is going to specify the path for the build process of the image. So Docker Compose, this is going to take a value that is a directory. And Docker Compose, actually I think you specify the file name if you want to. But I'm specifying a directory, and Docker Compose is going to look in that directory for a Docker file and use that Docker file to build the image. So I'm specifying dot. This is the same as when we built in the last lecture. I had that trailing dot, and I said that's not a typo. That's really important to have that dot there. This is the same dot. Build dot means look in the current directory for a Docker file and use that Docker file as your instructions on how to build the image. And then mapping the port. So last time we did in the command line -p 8080:8000, and I did local port as a parameterized and then :8000. What this is doing is mapping a local port on your device to a port within the container. So I'm saying I'm mapping local port 8080 to port 8000 inside the container, the app container, the container running the app service. This is the way that people are going to connect to my container, because your container is a virtual machine or a virtualized instance, I guess, inside your laptop. But you want people to be able to access that. First of all, you want to be able to access it for testing purposes, but you're not inside the container, you're on your laptop, not inside the container. And you eventually want people from outside your laptop, from the outside world, to connect to your app. So we're going to say any connections coming into port 8080 on my laptop, send that to port 8000 inside the container. So I'm mapping a port, which is going to forward requests for 8080 on my device to port 8000 inside the container. Question?
Just briefly, repeat, you were saying you were emphasizing not to use this in our implementation because it wouldn't work?
Yes, not exactly. There's one thing that you have to watch. I might just spoil it, actually. But you can't copy it exactly character for character. There's literally one character you have to change. Yes?
So the only way to get to port 8000 is through the local port?
Yes. You could. There is technically a way you could access it without using the local port. It's not something we really have to worry about in this class. I'll probably demo it at some point in the semester. But we can actually bounce into the container and go into the container and then access port 8000 directly from inside. And that may or may not be useful for your debug process. There's some times where I find that's useful. So you might want to, but we don't have to. We can access it from local posts too. Not sure if it matters, but the slides from the website are slightly different from what you're showing us. Oh no, are they? Does it have, I can't ask in person, but if the slides on the website that you downloaded, if it has a whole bunch of slides about databases, if they're like super different, go back to CSE312.com, refresh, and then download the slides again. I did update the link for the slides today. So if you refresh the page, you'll get the new link. It should be 1.6 Docker Compose, If it's 1.6 databases, you got the old versions of the slides from this morning. I updated them this morning because we're not talking about databases quite yet. But they should be. I'm pretty sure I did my usual thing of download it before class, but I want to just double check. Yeah, 1.6 Docker Compose. Yeah, and then it goes right into Docker Compose with no database stuff. Yeah, I cut out a lot of the slides for today's lecture. Yeah, just refresh the page. You should be able to get the latest slides. Can we switch the port the server is listening to from 8000 to 8080? Yes. What's the hyphen in front of the 8080 8000 mean? I forget exactly. I was tripping myself up on that a few slides ago. But I think this is defining a list where the other ones, I said list, but I meant key value pair, where build is a key with the value, key value being a list. I think the dash means this is a list of values instead of key value pairs. I'm quite sure. I'm not 100% on it, though. Yeah, so your ports, and that is the thing you got to pay attention to. Your ports do have to line up. I don't care what you use for your port inside the container. By default, I have it as 8080 in the handout code. It's 8000 here. That's the thing you need to pay attention to. Whatever you choose, they do have to line up. But you do have to use 8080 for your local port because that's what we're going to use for testing. It's in every testing procedure. That local port, the first one has to be 8080. The second one should match whatever you're using inside your container to run your app. And this causes a lot of confusion in the ports, so I made this beautiful visual. Oh, God, that looks worse than I remember. But I made this beautiful visual this morning. So you have your laptop. This is your device, your machine. And when you go to deploy, it'll be your server box. But whatever physical device you have that you're running this machine on, and then you're going to use Docker Compose to start up a container inside your laptop as a separate virtual device, virtual machine. I don't want to use virtual machine because it's not a VM, but a virtual container, I guess. But it's a whole nother effective machine, but it's running inside your laptop where nobody can access it. So somebody in the outside world who wants to connect to your app can't get there because they can only access your laptop. Or you going to your browser running on your physical device, on your local device, you go to your browser and you type localhost 8080, that request is going to your laptop, not to the container. So we need to tell Docker Compose, or Docker if we're running this command line with the -p command, we need to tell it, hey, whenever I get a request on my local machine, on my laptop, for port 8080, can you please forward that to inside the container? Forward that request to the container on whatever port I specify. So I'm specifying 8000. This is why I don't want to use 8080 twice in the slides because it would look a little confusing. But 8080 on localhost to my laptop, Docker Compose is going to get that request. It's going to grab that request and say, this is for app port 8000, and forward that request to the app inside the container port 8000. And then inside the container, your app is running, in this example, hopefully listening on port 8000 for that request, gets that request, responds to Docker Compose, and then Docker Compose is going to forward that over localhost 8080 back to whoever requested that, made that request. So this port is very important. Local port on your laptop and port inside the container. So whatever port inside the container, when we're grading, we're not even going to know what that port is. You can choose whatever port you want for inside the container, as long as this number is the same as whatever port you chose inside your code, because this is the only request your code, your server code, is going to see. Your server code isn't going to see the 8080. You can actually tell that by checking the HTTP headers. It'll still say localhost 8080, but you're going to get a request over port 8000. That's the only thing you're going to see. So if you're listening on 8000 inside the container and you're mapping 8080 to 8000 in Docker Compose, you get a request for 8080 on localhost on your laptop. It's going to be forwarded to 8000 inside your container. I just got a lot of questions about this. Hopefully this clears it up more. But if there are questions, I'd be happy to talk about this for another 30 minutes. Talk about ports all day. How do I share my laptop port with others so they can access my laptop? I might try to demo that. Can I be so brave to do that during the demos? But what's MIP? Yeah, I'm gonna get DOS. Hey, I do have an IPv4. So you give your IP address out, and then people can send requests to your laptop. I mean, that's one of UB's IP addresses. It'll change as I move around the network, so I'm fairly comfortable with that. I do want to check this quickly. The Spotify app's going to work this time. I swear, if it doesn't. I do want to check this quick, and then if this works, I'll explain it all in the demo. I've been having issues with Docker too, though. Everything goes wrong. Okay, there we go. Everything goes wrong when you try to live demo. Oh, I'm sad now. I might not. I'm going to be missing something. Either that or UB just blocks the port. Might be what's happening. If we have a little time at the end, I'll try to get that working, because I do want to get that working. It'll be a fun demo. That's the wrong slides. There we go. Okay. All right, let's get back on track. I'll explain all that, what I did. Even if I don't get it working, I'll explain all that when we get to the demos. What I just did there. So getting your ports matching, being what they're supposed to be, very, very important. That's all I want to say about it, unless there are questions. Like I said, I'll talk about it forever, but you probably don't want to hear me talk about ports that long. Let's talk about some juicier stuff. So then you use this file. Once you have this file saved as docker-compose.yaml, then this is going to be used by Docker Compose to build our container. And we don't have to do any of the -t and image name. We don't have to name our images. We don't have to do -p in the ports. All that information is here. We don't have to remember our trailing dot. All that information is right here. So we just do docker compose up. So there are a few different ways to use this command. Docker compose up will spin up your containers, your whole container network, if there are more than one containers. And build the images and then spin up your containers. Builds the images first and then runs them if the images have not been built already. There's -d. I briefly mentioned this last time. I'll briefly mention it here. This is detached mode. If you want it to run in the background forever, this is usually something you're only going to use when you're ready to deploy. If you're done with your app, you want your end users to go see it, do docker compose up -d. That's going to run it in the background. And then you can log out of that terminal window and have your app still running by Docker Compose in the background. The one we're actually going to use, the most important one, the one you should use every single time you run your container, during development at least, is Docker Compose up --build --force recreate. Why do you need two flags to do the same thing? I don't know. Ask the Docker developers. But this one is the one that works. If you just do --build, it won't rebuild your container if it's already been built. So, or your app rather, or oh my goodness, image. It's one of those three. If your image is already built with Docker Compose up, and you do Docker Compose up again or Docker Compose restart, it's not going to rebuild the images. It's going to restart the existing container. We want to go back to the image, rebuild the image with the Docker Compose and Docker files, and then create new containers based on the new images, and then run those as the Docker Compose network. To do all that, we say --build --force recreate, and that's going to make sure we start the process from step 1. If you don't do this, you don't see the changes to your code. So we want to do this in development because presumably you're restarting your app because you changed the code. If you don't rebuild the image and create a new container with the new image, you won't see the new code. You won't see your changes, and you'll be wondering why, no matter what you do, nothing changes how your app behaves, and you'll go so nuts. As I've done this before, I've seen so many students do this before. We'll all probably do it at least once in our lives. You add a print statement as the first line of main that says the app started. You rerun Docker Compose, and that line doesn't even print. And you're like, how the hell could that line not even print? Well, it's because you're not using your latest code. So make sure you build and force recreate. That's going to use your latest code, and you'll actually see the changes that you're making to the code actually have an effect. This will actually be being used. So this is the one you should be using in development, which is the entire course. I guess, except when deploying your project, I guess that's the one time where you'd use this command. Or you can do up -d --build --force recreate. You can combine the two and make sure you're rebuilding and run in the background. And then if you want to restart your container without rebuilding it, Docker Compose restart. This will be more relevant in homework 2 when we have a database. But if you do build and recreate, or even if you just do up, it can wipe your database. The build and force recreate certainly will wipe your database, which sometimes isn't what you want. You don't want to lose all your data. So this is the one we want. Docker Compose up --build --force recreate. Learn to love this command. If you don't, you might not see your new code in action. Okay, let's see this stuff in action now. Okay, so I have this, let's stop this, clear. So I have this app. It looks somewhat similar to the homework handout code. Notably, I have port 8000 just to make sure it works with my Docker Compose configuration. And I have threading, which you don't have in the homework handout. If you want to add threading, it's fine. It won't be relevant until homework 3, though, and I'll have a long conversation about it. And I'm just responding with hello. I'm ignoring whatever the user sends to me and just saying hello, no matter what they said to me. And just printing what I receive from the client. And I have this at 1K instead of 2K. I'll change it to 2K. I did have issues. Some students were getting requests that were larger than 1K, so I changed that to 2K in the handout. And everybody has 2K now. Don't have those issues anymore. And I have a Docker file. And we can run this with the Docker file. If you're using a Docker file, you're using a Docker file, make sure you have this -u here. I mentioned this once in lecture before, but it's worth repeating. Make sure you have this -u here. It's a very important 2 characters. Everything will run just fine without the -u, but without the -u, you won't always see your print statements or error messages on the screen when you run in Docker. You'll see them when you run with Python, but not with Docker. The -u means don't buffer the output. It's run this unbuffered, so it'll display output immediately. Docker otherwise will buffer your output from your Python program, and you won't see it until the buffer's full or until it decides to flush the buffer. So -u, you're going to see your output when you run using Docker. So let's run this using just Docker to start. So it was Docker -t, then whatever image name I want. I'll choose my app. I'll use lecture app because I think I already used my app before. Lecture app, and then a trailing dot to make sure that it's looking in this directory for a Docker file. It's going to read this Docker file. I don't have any requirements to install. I don't have a requirements.txt, so I removed that line. Not necessary for this simple app. And I didn't have my build. I have to tell Docker what I'm even trying to do. I'm trying to build an image. So Docker build. Oh. I was not aware of that. I've never tried to name an image with a capital letter before. Is that true? Anyway, so now I have my image, and I can do Docker images to view all my images. And I have my lecture app right here. So lecture app, built 6 seconds ago. It's a gigabyte. And I can use that Docker run to run my app. I'm going to specify the port. I'm going to map local port 8080 to 8000 inside the container. And I'm going to use lecture app as my image. Yes, that's true. So if you see this error, port's already allocated. You might see this error from Python. You might see it from Docker. In web development, I don't know. I'm just used to seeing this error all the time. It means somebody else is already using that port. So when I try to get port 8080, only one process on your device can be using a specific port. So if some other process is using port 8080, I can't use that port in my work. And the culprit is always myself. It's always you. You're going to be the one who's already using that port. I had another process running where I was testing this app. I had another process in a Docker image, Docker container that was running that already went to the operating system and said, yo, I need 8080, give me 8080. And then I can't use 8080 because I'm already using it. So that's what happened there. Now I'm going to run and it should work. Starting the server, which is right here. That's what I just mentioned, a print line right at the beginning of main because I like debugging too. Sometimes print statements are helpful. It's the quick and dirty debugging way. If you need I need to know if my app is even running. There's no unit test that's going to help you there. So starting the server. So that means we got into Python. I'm going to go to my browser. I'm going to do this in a little bit smarter way. I'm going to go to my browser, localhost 8080, and it should say hello. And I can see all the output from my server. I'm printing out the length of the data that I received, printing out the IP and port that sent the request. I got 743 bytes, and this was the message, this in bytes. Oh my goodness. This is the message. It's a request for my root path. I didn't specify any path, so it's a request for the root path. We got all this stuff that we would expect. The host is localhost 8080. So even though my app is listening on port 8000, the host is still going to be localhost 8080 because to the end client, when I went in my browser, that's what the end client connected to. It said, connect me to localhost 8080. So that's what that header was set to by the browser. That doesn't change just because we're forwarding to a separate process inside a Docker container. Trailing blank line, never forget that. And then I'm decoding and printing it again, just so it's in a more human-readable format. And I can see all my information. I have all my headers. There's all kinds of headers that modern browsers will add, including a cookies header or a cookie header. It's what we would expect. Okay, so needless to say, my app's running. So let's kill it. I'm going to do Control-C to kill that. Or you can use Docker Desktop. You can take a look at where the hell is my containers? This is covering up. Oh, that notification was covering up part of my stuff. I can look at my containers. In here, I can stop them. There's a lot you can do in Docker Desktop. You never need to use Docker Desktop, but it can be easier if you want a GUI instead of doing everything command line. It's very helpful. And I might use it here because my app doesn't seem to want to die. So I'm going to go here. I'm going to stop my container. Hopefully it doesn't take forever. Okay. And I got my terminal back, so I know it stopped. And now let's do the same thing, but with Docker Compose. Docker Compose up dash dash build dash dash force recreate. So this is going to do the same thing, but it's going to run through Docker Compose. I don't have to remember my ports or anything. That's all in my Docker Compose file, which is exactly the one from the slides. Oh, not exactly. I didn't change my version. So you can specify the subversion instead of just the minor version, instead of just the major version. But I'm just going to specify the major version here. And you'll get output that looks like this. Now, the first time you run Docker or Docker Compose, it will take a lot longer than it took here because it has to download Ubuntu first, or the Python image, which contains Ubuntu. So we'll have to download that first. So the very first time, it's going to take a while. And afterwards, it doesn't take all that long. Until we start installing dependencies, it takes a little bit longer, but not too bad in Python. And now if I go to the browser again, doing this the dumb way again, localhost 8080, and it still works. It's the same exact thing, in fact. I guess the only real difference is when I get standard out, it's going to tell me which container printed something, because I can't have multiple containers running with Docker Compose. So it'll say this container has something to say, and then whatever it's trying to say. And I can't get it out of my brain that that's not what I should click. So the question of how do I let people who don't have access to my laptop check out the stuff that's running on my laptop? So you do have a public IP address. So there's actually no good way, no way at all, I guess. There's no way to know your public IP address from your device itself. But you do have a public IP address that the outside world can connect to you from. To find out that IP address, because right now your laptop can talk to UB's network, and UB's network is going to be like, oh yeah, your IP address is 192.168 something something. If I ask, if I go to my settings and take a look at my IP address, my IP address is this, apparently. I wonder if this will work. That shouldn't. That should be a local IP, but that doesn't.
It worked when I tried it. We just tried it.
To connect to my app?
Or like to connect to my app.
Oh, okay. What port did you use as your local port? And it did work? Oh, hey, there we go. Were you able to see each other's or just your own?
I ran my app and then they were able to connect to it.
Okay, cool. So for some reason, what's my IP was not super helpful there, unless by chance my IP changed. No. I wonder why it didn't work this way. So with let's do this. So you have to connect. Well, that kind of blows my point because I went into my computer settings and asked for my IP. So maybe UB's routers are telling me what they gave me as a public IP address. Usually it doesn't work like that, but maybe UB's network works differently. So if y'all can connect to this and see if it says hello to you, that'll be our ultimate test. Then we know it's not a local IP. It doesn't look like a local IP, though. But usually you'll just get your local IP address from the router, and to figure out your actual IP address, you have to connect to something outside of your network, so outside of UB's network in this case, and say, hey, what IP address did you see when you got this request? And then it sends that IP back, and that's what what's my IP doing? It worked? Oh, man. So that's deployed to the world. My beautiful app. So that's your answer. Get your public IP address. And if you have a web server running on your laptop, it's already deployed to the world. If you are doing this at home, it is a little different. So UB's network is clearly working in a way that I wasn't expecting just now. But if you're doing this at home and you get your IP address, it'll usually say 192.168.0.12 or something like that. The last number will usually vary. That's a local IP address, meaning that's only your IP address from within your network. And then if you have another device on your network, actually that's why this one's working and the public one isn't, because I'm on UB's network. We're all on UB's network. We don't have to talk to the outside world. From outside of UB, like if somebody has a VPN and tries to connect, I don't think this will work, but maybe it'll be an experiment if somebody does. And then if somebody's on your network, that IP address will work, but you want to get your public IP and then have somebody connect to that. But your router is going to control that IP address, your public IP address. So a request for that IP address, your public IP address from your home, is going to be a request to the router, and the router's not going to know what to do with that. It's going to look at that request and say, I ain't no web server, and just ignore it. And that's where we use port forwarding, kind of like mapping the ports that we just did in Docker Compose. You would log into your router's settings and then forward that port, whatever port you want people to use, preferably 80 or 443 at that point, and say, if you get a request for this port, please forward it to my laptop. And then your laptop would be running your software, your web server, and get the request, and then send it back to your router, and then your router would send it back to the world. So that's how you would do it at home. You'd have to do some port forwarding. Yep.
I'm not on, assuming I'm not on the same network you're on, I can't connect to that.
You can't connect to it? Okay. I want to get this public port working. We're going to give this a shot. I know this is a bit of a tangent, but I have one plan. I'll only try one more thing. Is from the outside world, it's likely that UB's network is blocking port 8080. So what I want to do is run my app on port 80, which hopefully I have nothing else running that's taking up port 80, which I might. I'm going to use local port 80, which is the default for HTTP. So UB shouldn't be blocking port 80. It's what we use for the internet. It's possible that they are, but we'll see. So let's use port 80 and see if that public address will work. So now, man, that's like the 5th time I did that. So now when I go to localhost, instead of specifying the port, which I can go to localhost:80. That would work. But since 80 is the default for HTTP, I can just type localhost. Yes, I know that didn't work. Get off my back, okay? If I just go to localhost, it'll take me to the site. The reason it didn't work is because it assumed I wanted HTTPS, and the default port for that is 443. So I had to actually type HTTP without the S and then go to it. So let's try it over here. No. So I'll speculate, but I'm guessing that this is going to be a port forwarding issue. I have to go to UBIT and say, can you forward port 80 to me? But they're not going to do that for me. That seems like it's not the full story, though. I feel like something else is going on here. But I'm not going to waste more time doing it. So next time, I'm going to give some demos. I think I did all the demos I wanted to do today. Next time I'll do more demos. I have stuff planned for like encodings, and we're going to break images. I don't think I have enough time to do any of them now. So let me double check questions, and I guess we'll just go. Mom's disappointed at me. I'm glad I read that during lecture. All right, yeah. Yeah, I don't have time for any other demos, and this one kind of wrapped up. So let's just do this. Let's just go.